Hello everyone, welcome back to Sine Theta Math. In this video, we will be going over Unit 4 of Precalculus Honors, aka the start of learning trigonometry. Now, in this unit, we learned about the properties of different trigonometry functions: sine, cosine, tangent, cotangent, cosecant, and secant. And this unit review will be going over all those properties so you'll be ready for the test tomorrow. Now, let's start off with question 1. Solve the problem. For what numbers theta is f of theta equals cotangent of theta defined? It's a bit of a confusing question, but we can just start off by asking the opposite of it. Instead of asking where all of it is defined, let's ask for what is undefined. It's much easier to find that it's undefined because it's a smaller range of numbers than defined. Because if we look at cotangent of theta, it would look something like this. You see, it's defined for this big range of numbers right here, but then it's not defined for like this number right here or this number right here, and it's just singular numbers that look periodic. And it like looks like it's repeating in a pattern. So it'd be much easier to ask where is it undefined, and you can see that also in the answer choices. Except all real numbers except blank, all real numbers except blank, all real numbers except blank. So it probably wants you to find what's undefined and then use that to find your answer choice. So in order to do that, let's think about what is cotangent of theta. Well, cotangent of theta is equal to 1 over tangent theta, which is equal to 1 over sine theta over cosine theta, which is equal to cosine theta over sine theta, because you can just drag this denominator up to the top and keep sine theta down there. That's just a rule of like fractions. So now when we have this sort of function over function sort of thing, it's usually undefined when the denominator is equal to 0, right? Because you can't really divide by 0. So when is the denominator 0? Well, that's when sine theta is equal to 0. Now, if you remember the zeros of sine theta is 0 when when theta is equal to a multiple of pi. And as you can see, in our answer choices, all real numbers except integral multiples of pi is one of our answer choices. This would be the correct one, because integral multiples of pi just means the real multiples of pi, which would make sine theta equal to 0. Good. Now, what is the range of the tangent function? The range of any function is basically all y values that come out when you put in an x value. So, we want to find the range of tangent theta. An easy way to do this is just to look at the graph of tangent theta. As you can see, it's going to look something like this, you know, all of these curves coming up and down. And as you can see, it just extends up to infinity and negative infinity, meaning it covers all numbers on this y-axis, from negative infinity to infinity. So that means that it covers all real numbers up and down, so C would be our correct answer choice, because it just extends to all real numbers. For this next question, it asks us to use the fact that the trigonometric functions are periodic to find the exact value of the expression. Now, when we think of the periodicity of a trigonometric function, immediately go to the 2 pi, I like to call it the 2 pi rule. Now what does that mean? Well, if we have sine of an angle theta, or cosine of an angle theta, well, this is equal to sine of theta plus 2 pi, which is also equal to sine of theta plus 4 pi, and so on and so forth. Multiples of 2 pi, if you add that to an angle in a sine or cosine function, you'll get the same thing afterwards. Because you can see that in a graph of sine, see that it just keeps going up and down, up and down. I know it's a very bad graph of sine, but it has a period of 2 pi, meaning it just keeps repeating over the interval 2 pi. So 0 to 2 pi is going to be the same as 2 pi to 4 pi is the same thing as 4 pi. So you can just keep adding 2 pi over and over again, and you'll still get the same answer if you put it into the sine function. And this also goes for 360 degrees, because 360 degrees is the same thing as 2 pi when we're talking about sine, cosine, and stuff. So you can add 360 to an angle of sine, or you can add 360 to an angle of cosine, or add 2 times 360, and so on and so forth, and you'd get the same answer out of sine or cosine. So great. Now that we've mentioned that, we can move on to solving the equations right here. So, tangent of 13 pi over 4. Well, we don't really like 13 pi over 4 because it's bigger than 2 pi. And since it's bigger than 2 pi, we can subtract 2 pi so that we get, and we can keep subtracting 2 pi after that to get to a range where we like. Now we want it to be in between 0 and 2 pi, so then we can use a reference angle on the unit circle, and then we can hopefully find the answer pretty easily. So let's subtract 2 pi and see where this gets us. So 13 pi over 4 minus 2 pi. Now to subtract 2 pi from this fraction right here, we have to make sure the denominators are equal. So we can do that by having the 4 down here, and then multiplying 2 pi times 4, which is equal to 8 pi. So then we can rewrite 2 pi as 8 pi over 4. And if you reduce 8 pi over 4, you just get 2 pi again. So when we do this, we can just subtract across. 13 pi minus 8 pi is just going to be 5 pi. And then the denominator stays, so 4. Now 5 pi over 4 is less than 2 pi and greater than 0. So that's good. We are in a range where we can use a reference angle. Now, when I look at this, I don't really like 5 pi over 4. Like, what is 5 pi over 4? So what I'm going to do is I'm going to convert this to degrees, because I just like looking at degrees better, like a circle. Degrees just, it feels more natural to me, and also in the triangles, it's like 30, 60 degrees, 45, 45 degrees, So let's convert this to degrees. And the way we do that is we take this number, and it's in radians form because it has this pi, and it's not like a degree or something. We take it 5 pi over 4, and then we multiply it by a conversion factor of 180 over pi. Now you can see that this pi and this pi will cancel out, and we're just left with 5 over 4 times 180. Now you can work this out. 180 divided by 4 is equal to 45, and then 5 times 45 is equal to 225. And there we have it. We have our angle of 225 degrees. Now, 225 degrees is in the third quadrant. Remember, like right here we have 180 degrees, and then right here we have 270 degrees. So 225 is going to be somewhere here. So when we have an angle in the third quadrant, to find the reference angle of that angle, we use this rule. The reference angle, which we'll call theta, is going to be 180 plus theta. So to find the reference angle, we just have to, this is going to be equal to 225 degrees. I know that's a bit confusing. Let me re-explain. So if we are in the third quadrant, to find a reference angle, the reference angle is going to be that reference angle plus 180, and then we get the angle that we want to get the reference angle of. Or we could rewrite this as the reference angle will be whatever angle we have, which is 225, minus 180. And if you work this out, 225, 180, subtract 5, 12, 1, we get 45 degrees. And that is going to be our reference angle, which is in quadrant 1, which is good, because if you want to know the tangent of 45 degrees, just draw the special right triangle, 45, 45, and the hypotenuse will be square root of 2, the sides will be 1 and 1, and then you can see that the tangent of 45 degrees is 1. Now, 1 is an answer choice to our question, but it's actually not the correct answer choice. The reason being is because we moved quadrants, so the answer won't be the same. Because think about it, in this first quadrant, tangent of an angle is positive, but down here, tangent of an angle is negative in this third quadrant. So we have to flip our answer because we flipped signs. See, we went from negative to positive, So we have to multiply 1 by negative. So our final answer will be A, -1. Sorry, Siri accidentally activated for some reason. Alright, now we have to find tangent of 390 degrees. This one's a bit simpler because we don't have to convert from 5 pi over 4 to another angle and then find the reference angle. We can just subtract 360 degrees because remember, 360 degrees is equal to 2 pi. So let's just subtract 360 from 390. Remember, we'll still get the same answer. 0, 3, and these just cancel out to be 30. So our angle that we have to use is 30 degrees. Now, what's tangent of 30 degrees? Well, again, draw your reference triangle. 30 degrees down here, square root of 3 on the bottom, 1 on the right side, and then 2 on the top. Tangent is opposite over adjacent. So tangent of 30 degrees would be 1 over square root of 3. But we don't have 1 over square root of 3 here because we have to rationalize the denominator. And to do that, we take 1 over square root of 3, and we multiply it by square root of 3 on the top and square root of 3 on the bottom, so that these square roots multiply to just cancel out. And that way we get, on the top we get square root of 3, and on the bottom, since we multiply, whenever you multiply square root by square root, you just get that number back. So the square root of 3 times the square root of 3 is just 3. And there we have it, square root of 3 over 3, which is an answer C. Great, that's the first page done. I don't even want to know how long this recording is already. I'm sorry, I'm dragging a lot of things out. Now, for our next question, if sine of theta is equal to -0.3, find the value of sine theta plus sine of theta plus 2 pi plus sine of theta plus 4 pi. Now, some people may try to find the angle theta and then plug it back into here and then find the value. You don't need to do that. Remember, in the last equation, or last question, we were talking about the periodicity of sine and cosine. And we talked about how if you add 2 pi, or if you add 4 pi, or 6 pi, it's still the same thing as sine of theta. So we don't have to go and find theta. We can just rewrite this as sine of theta, and sine of theta plus 2 pi is the same as sine of theta. And then sine of theta plus 4 pi is just the same thing as sine of theta. And you can add these all up to 3 times just sine theta. Now what's sine of theta? Well, it gives us here in the problem. Sine theta is equal to -0.3. So this is the same thing as multiplying 3 times -0.3, which will be -0.9. And there we go, that is our answer B. So you see, we just replaced sine theta with -0.3, and we jumped from sine theta plus 2 pi and sine theta plus 4 pi to sine theta because it's periodic over 2 pi. So if you keep adding 2 pi, the answer will still say the same as the original angle. Now, we have to find the quadrant that the angle theta lies in. Now, we're given two conditions. Cosecant is greater than theta, or cosecant theta is greater than 0, and secant theta is greater than 0. So that means that they're both positive. Now, let's convert this to sine and cosine so that it's a bit easier when we look at the unit circle. So cosecant is just 1 over sine. But if 1 over sine is positive, that means sine is positive. Because 1 over a positive number will give you a positive number. And same goes for cosine. So sine theta has to be greater than 0, and cosine theta has to be greater than 0 because secant theta is greater than 0. Because secant is just 1 over cosine. If you divide a positive number by a positive number, you'll get a positive number back. So sine theta is greater than 0 and cosine theta is greater than 0 because cosecant and secant are greater than 0. Now, if we take a look at our unit circle, the only place where sine and cosine are both positive is in this first quadrant, because sine is positive, cosine is positive, and tangent is positive. So sine and cosine are both positive. So you see, we just converted cosecant and secant back into sine and cosine. We just flip them, and if you flip a fraction, it'll stay positive. I probably should have said that instead of 1 over a positive number. But yeah, if you flip cosecant, the sign will stay the same. So if cosecant was negative, sine would be negative. If cosecant is positive, sine would be positive. And if secant is negative, cosine would be negative. But if cosine is positive, or if secant is positive, then cosine is positive. I hope that makes sense. Basically, if you have this greater than 0 and you flip it, this will also be greater than 0. That's basically what I'm trying to say. Now, our next question asks us to use the given values of sine and cosine to find the function value. Now, we have sine of theta is equal to negative 7, the square root of 7 over 4, and cosine of theta is 3 over 4. Now remember, in our first question when we were rewriting cotangent of theta is equal to cosine of theta over sine theta. But wait, we have cosine and sine theta, so we can just plug them into here, and cotangent of theta will be equal to that. So, our cosine value is 3 over 4, so we'll write 3 over 4, and I'll put it in parentheses, over sine theta, which would be negative square root of 7 over 4, square root of 7 over 4. Now, if we multiply the top and bottom by 4, the fraction will stay the same, and all of the 4's will cancel out, and we'll be left with 3 over negative square root of 7. Now, we have to rationalize the denominator, so we multiply by negative square root of 7 on the top and bottom. Now we'll get negative 3 square root of 7 on the top over these square roots and negatives will turn into just a positive 7. And there we go, we have our answer, D. Now, our next question asks us to find the exact value of the expression. Now, at first, when you look at this, you're like, oh, what is tangent of 55 degrees? Or what's sine and cosine of 55 degrees? That's not in the unit circle, or we don't have a reference triangle for that. That's fine. You just have to remember the fact that tangent is sine over cosine. So if we have tangent of an angle, it's the same thing as writing sine of that angle over cosine of that angle. Now, what's the angle we have? 55 degrees. And then we have to subtract sine of 55 degrees over cosine of 55 degrees. But wait, these are just the same thing. So if we subtract them, we'll just get 0. So that's our answer, A, 0. Our next question asks us to find the exact value of the requested trigonometric function of theta. Now, we're given that cosecant of theta is equal to negative 7 over 4, and theta is in quadrant 3. Now I'm going to draw a coordinate plane to the side here. Now we're going to be in quadrant 3, so I'll just draw a line out here, and then this angle will be theta. Doesn't really matter. Now, we're given that cosecant of theta is negative 7 over 4. Now, when you think about it, cosecant of theta is just 1 over sine, meaning we can just flip whatever sine is in a coordinate plane. Now, if you remember, sine is sine is y over r. So if we flip that, we get r over x for cosecant of theta. So this is our r value, and this is our y value. Now, obviously, our r can't be a negative number, so our y value has to be negative because this is negative. So our y value is going to be 4, or negative 4, and our r value, the length of this line right here, is going to be 7. Now, since we need cotangent of theta right here, we need x over y, because tangent of theta would be y over x. Cotangent, you flip that, and you'll just get x over y. So we have to find the x value, and I'm just going to mark that right here as just x. X is going to be negative because we're in quadrant 3, so just keep that in mind for later. And if you see, I can connect these lines, and I just get a right triangle. Now this hypotenuse is 7. This side right here is equal to x, and this side right here is equal to y. Now we can solve for x using Pythagorean theorem. So right here we have our, I'm going to write this over here, our r value, our hypotenuse, is 7, so we square that is equal to, my screen keeps turning off, I'm sorry. And then we can put 4 squared, and then plus our unknown value, our unknown side, x squared. Now we can subtract 4 squared on both sides, so we get, and I'll expand out the squares. 7 squared is 49. If we subtract 4 squared, which is 16, we get x squared. Now then we get, now if we do this, we get 33 is equal to x squared, and then x is equal to plus or minus the square root of 33. Now, since we said x is negative earlier because we're in the third quadrant, we don't take this plus, we just take negative square root of 33. Now great, we have our x value, we can just plug that into cotangent because cotangent is x over y. So, we'll have square root of 33 over our y value, which is just negative 4. Now, as you can see right here, our answer will be C because these negatives will cancel out, and we'll get square root of 33 over 4. Now, we're given the second one. Secant of theta is 9 over 8. I think, yeah, 9 over 8, and theta is in quadrant 4. Now, let me draw out a coordinate plane right here. We're in quadrant 4, so that means that our y value will be negative and our x value will be positive. Now, secant of theta, for the same reason that cosine or cosecant of theta is x or r over y, this will be r over x because cosine is x over r. So we just flip that for secant because secant is 1 over cosine, and we get x over r, or r over x, sorry. So 9 will be our r value, and 8 will be our x value. So now we can extend this out. We know our x value is 8, and our y value is, or our r value is 9, and we want to find our y value. Now, we have 9, now we can use Pythagorean theorem to solve this, so 9 squared is equal to 8 squared plus y squared. Now I'll expand out the squares and then subtract 8 squared from both sides. So we'll get 81 minus 64 is equal to y squared. So 17 is equal to y squared, which then means y is equal to plus or minus the square root of 17. Now if we take a look at quadrant 4, our y value has to be negative. So we take the negative square root of this. And then we're trying to find tangent of theta, which is y over x. So we take our negative square root of 17, and then we put it over our x value, which is 8. And as you can see, our final answer will be negative square root of 17 over 8, which is B. Now we have to find the amplitude or period as requested. Now we just have to find the amplitude of this equation, y equals negative 3 of sine 5x. Finding the amplitude is pretty easy. You just take this first number right here and take the absolute value of it. And the absolute value will get rid of this negative, and we just get 3. So the amplitude will be B, 3. Now we have to find the amplitude and period of the function without graphing. Now, to find the amplitude, again, take this front number that's being multiplied by a sine, take the absolute value of it, and we get 3 over 4. Now, we can cross out a few answer choices just by getting that. We can cross out B and D, because these are not the right amplitudes. Now, to find the period, we take whatever number is being multiplied by x and do 2 pi over that number. So, we can write this as 2 pi, so our period, which we write as p, is going to be equal to 2 pi over this number, which is 2 over 5. Now, let's cancel out this denominator by multiplying by 5 on the top and bottom. And we will get 10 pi on the top, and then this 5 and this 5 will cancel out, so we'll get 2, and this will simplify down to 5 pi. So our period is 5 pi, meaning our only answer is A. I know I kind of rushed through that one, so I'll just go back through it. The period is going to be this number multiplied by x. You'll do that, 2 pi over that number, and it has to be the absolute value of the number. I almost forgot that, that's crucial. Like, so you have like a negative number here, you'll have to take the absolute value of that. If it's positive, it doesn't really matter, but you have to take the absolute value of the number it being multiplied by the x, and do 2 pi over that absolute value of the number. Now, find the equation for the graph shown here. Now, let's start off by finding the maximum minimum of this graph, because that'll tell us a bit about the amplitude, and it'll be easier to go from there. Now we can see that the maximum of this graph is 2, and we can't really see the minimum here, but we can see that it's kind of starting to level out at around -2. So we can rule out that this function's amplitude would be 3, because because the amplitude of the function would just be the maximum would be the amplitude of the function, just the absolute value of the amplitude, which would be 2. So we can already rule out that B and C are not the right answers because 3 is in the front of them. If we had 3, then the maximum would be up here and the minimum would be down here. We don't have that. We have it 2. So now it's a matter of, is it cosine of 3x or is it cosine of 1/3 x? Now, cosine of 3x would shrink the graph by a factor of 1/3 because this number right here is greater than 1. But here, we see that the graph is kind of being stretched out, you know? Like usually cosine would have crossed through here and here and here and here and stuff, and here and here and here and here. Something like that? Not like that, but something. But you see, like, it's kind of stretching out, you know, taking its time to go. So it wouldn't be 3x because 3x would make the graph go more faster. This is kind of making it longer. And you can do this more carefully by looking at the periods of the two functions. So if we took the period of this, we take the absolute value of this number, do 2 pi over the absolute value of that, so we get 2 pi over 3. Now you can see that the function would go back to being 1 after 2 pi over 3. But as you can see, the function is still taking its time to go down to the 0 and then the minimum after 2 pi is crossed. So this is obviously incorrect because we haven't gone through a full period on this graph over an interval of 2 pi over 3. So we just select D. Write the equation of the sine function with the given characteristics. Now we're given that the amplitude is 5 over 3 and the period is 5 pi. Now, I'm going to sit up. The amplitude is just that beginning number. So we'll just write y is equal to, we'll put the amplitude in front, 5 over 3, times sine of a number multiplied by x. Now how do we find that number? Well, we're given the period is 5 pi, so p is equal to 5 pi. But that means that this is equal to 2 pi over the absolute value of some number. And to make it simpler, since all of our answer choices have a positive number being multiplied by the x, I'm just going to get rid of this absolute value so we can just focus on this. Now, to get b, I'm going to flip both sides, so we'll get 1 over 5 pi, because I flipped this 5 pi, is equal to flip b, so b is on the top now, and then we have 2 pi. Now to get b alone, we multiply by 2 pi on both sides, and this 2 pi and this 2 pi will cancel out, and you'll see that this pi and this pi right here will cancel out, so we just get that b is equal to 2 over 5. And b is the number that we have to put in front of the x. So we get 2 over 5. Now, if we take a look at our answer choices, the only answer choice that matches that is D. Alright. Now we have to find the phase shifts of the following functions. Now a phase shift is this number right here, this whole number, whatever is being added to something multiplied by x, divided, we take the negative version of this number, so this number is c, so we take negative c over this number right here that's being multiplied by x, which is called b. So if we look at it right here, the negative version of this number is just going to be positive pi over 2 because this is a negative pi over 2. Just flip that, you get pi over 2. Not flip, just multiply by, or just take away the negative because you're multiplying by a negative. So we'll get pi over 2 over b, which is just 4. Now, if you just multiply the top and bottom by 2 to get rid of this 2 on the denominator right here, we'll get that the final phase shift is pi over 8, because then this 4 times 2 will go over here, and then this 2 and this 2 will cancel out. And that corresponds to answer C. I know it's a bit blanked out right here. I had to erase my paper to record this video, and I just kind of just went like this, and some of the regular stuff got ripped off, so I'm sorry if it's, you can also see my pencil marks like right here, not right here, or right down here. You'll see this graph that I kind of just scribbled out, and I was trying to solve this equation. Well, let's go on to the next question. So again, negative C over B. So our negative C will be just positive 5, because this is negative 5, over B, which is 2 pi. And right here, we can't really simplify it. It's just going to be 5 over 2 pi, because, you can't simplify 5 over 2. But it corresponds to this right here. Now, here is where I have some bad news. I could not solve this equation properly. I have no idea how you'd go about this. It just says fit a sine function to the data in the table, but I spent a while messing around in Desmos outside of school and just like looking at the equation, just trying to find something, and I couldn't really find a way to do it properly, and I looked online for a solution, and it was either locked behind a paywall or just no one knew what this question was. So I'm sorry, I can't provide a proper answer to this. Graphing the function, I don't know. I guess you can just like draw out this and then draw out like some of the numbers and then just make up like a sort of fake sine curve. I can't find a way to do it properly. I guess it's an estimation one. It just wants you to graph them all out and then kind of make a sine curve, but I'm sorry, I can't figure out how to do this. Anyways, we move on to our last page, and this page deals with graphing these two functions and then some inverse function. Now, to graph secant of something, firstly, let's find firstly we have to graph cosine of that function. Now, why? Because secant is 1 over cosine, so if we graph cosine and then we take 1 over that, we'll get a shape. We'll get the shape of secant, but it has to be in relation to cosine of whatever this input is. So we have to find some properties of cosine of 1 over 4x. Now, the maximum and minimum of this function is going to be 1, negative 1, because the amplitude here would be 1. And the normal cosine function is bounded between 1 and negative 1, so I'll just mark that here with like these little lines. And we have this 1 over 4 times x. So the period is going to be 2 pi over the absolute value of this number. I'll just write it as 1 over 4 because it's already positive. And we can multiply the top and bottom by 4, and we get that the period is just 8 pi. Now, to find some more critical points, let's multiply 8 pi, or let's divide 8 pi by 4, which I guess we kind of just did here, but 8 pi divided by 4 is equal to 2 pi. So, let's start off with this value right here. And then, after that, we take this 2 pi, go right here, and then we add another 2 pi when we get to 4 pi, and then we'll just go down here, and then we add another 2 pi, we get a 6 pi, and we go back up to 0, and go back to 1, and you can do the same over here. So you see we get a nice sine curve, or nice cosine curve now. Oh crap, I can't really see what I'm doing, like I have my hand like this. Let me just try it. Yeah, I'm sorry. Like my hand is like gripping on its screen. I can't like properly do it, but you get the idea. Let me try it again. Nope. I think this is the best I'm gonna get, right? It doesn't really matter. This isn't the main part of what we want. Now, in order to graph secant, remember that the shape of secant is going to be like this sort of parabola thing, bouncing on each of the maximum minimums of the function. That's just the thing you'll have to remember when you're graphing cosine and secant, or cosecant and secant. So to find where those parabolas will go up and down, we have to find the zeros of cosine. And that's why we graphed all of these critical points right here. And I'll just add like little dotted lines to show where we have to actually draw, because we're going to erase cosine afterwards. So yeah, we see we have these little bounded lines. So now for here, since cosine is positive, this entire parabola thing right here, it's not really a parabola, I just call it that because it looks like a x squared thing, is going to be pointing upwards because cosine is positive. Now here, cosine is negative, so the little curved thing will be pointing downwards because it's negative. Now right here, it'll be pointing upwards. And there you go. You graphed cosecant, or you graphed secant, and then you'd have to erase sine. I'm not going to really erase it right now because it would take a bit too long, but oh well. Yeah, you just erase sine on your paper, or cosine on your paper. Sorry for the cut, I had to take a bit of a break there. Now we have negative 3 times tangent of x plus pi over 4, and we have to graph this. So let's find a few properties. Firstly, this negative out front will flip sine, or flip tangent, so that instead of it going from down to up, we're going from up to down, okay? Now, tangent is periodic over pi, so, you know, this, if you add pi, it'll go like this, sort of like that. But that's if you just have tangent of x. Right here, we don't have tangent of x, we have tangent of x plus pi over 4. So we have to find, when is this equal to a multiple of pi? So we can find that it'll be equal to a multiple of pi. This n just means like a number that you multiply by pi, so 1, 2, 3, or 4. We can just subtract pi over 4 on both sides to get that, well, it'll be periodic upon a multiple of pi minus pi over 4. Alright? And that just means that the graph will be shifted to the left, pi over 4 units. So we can start off by finding the, and then, oh god, I'm losing it right here. Now let's find a few vertical asymptotes so that we know where we're supposed to be putting our curves. And we only have to find one actually, and then we can just keep going on because we have a period right here. And to do that, we have to find out when the, I'm sorry, I've been recording for so long, and I'm kind of just like, I'm getting so tired, but to find these vertical asymptotes, we'll have to find out when this is equal to an odd multiple of pi over 2, because that's when cosine is equal to 0. And remember, tangent is sine x over cosine of x, or sine theta over cosine theta. So when cosine of theta is equal to 0, we'll have a vertical asymptote. So we have to find when x plus pi over 4 will be equal to an odd multiple, so we can write that as 2n plus 1 of pi over 4. Or pi over 2, sorry. Now we'll get that x is equal to 2n plus 1 times pi over 2 minus pi over 4. Now we only have to find one vertical asymptote, and then we can use our period to our advantage afterwards. So we'll just use n equals 0 as an example. Now if we have n equals 0, we'll have pi over 2 minus pi over 4, which means that we will have a vertical asymptote at pi over 4. So I'll just mark that in between 0 and pi over 2 right here, so pi over 4. And in between, we'll have 3 pi over 4. And I'll just label all these so that we have a 6 pi over 4. Or no, 7, that'd be 7, sorry guys. 7 pi over 4. And then 9 pi over 4. And then 11 pi over 4. And then 13 pi over 4, I believe. Yeah. And right here, negative pi over 4. Then we have negative 3 pi over 4. So yeah. Now remember, we have a vertical asymptote right here. Now remember, tangent is periodic over pi. So if we add pi to this, we'll get 5 pi over 4. We'll get another vertical asymptote. And if we add pi to this, which would be, we just add 4 to this number right here, we get 9 pi, and we'll have a vertical asymptote right here. Same thing going backwards. If we subtract pi, so we subtract 4 from this number, we'll get negative 3 pi over 4, which will be another vertical asymptote. And then after that, we can find a 0 of the function, And then this part right here will give us our 0. So if we plug in n equals 0, we'll get that negative pi over 4 is 0. If we plug in n equals 1, we'll get that 3 pi over 4 is 0. And if we plug in n equals 2, we'll get that 7 pi over 4 is 0. And now from there we can draw our tangent sort of curve things. Remember, they'll be going up and down in between these vertical asymptotes. And they'll be hitting these zeros, and then we'll do one over here as well. So yeah, that's basically how you do it. You might just want to rewatch that, like, to see what I do, because I know I explained that really badly, but I'm getting so tired. It's almost 9 o'clock. I've been recording for like an hour now, so sorry. Alright, now our next two problems deal with inverse functions of trigonometric functions. Now, when we have the inverse of a function, of a trigonometric function, this basically means that we'll take a value that was outputted by a sine, cosine, tangent function, and we'll get the angle that would produce that value. So a way to think about it is we go from an angle to a value, right? We like put sine of 30, sine of 60, sine of 45 in there, and we get a value out. An inverse trigonometric function would go from that value you get from the sine function to the angle that you'd have to put into the sine function. So basically you're going from value to angle instead of angle to value. So we have to find inverse sine, that's how you read this, inverse sine of negative 0.5. Now to find that, we have, this will just be the angle that you have to put into sine to get negative 0.5. So, in order to find that, let's start off by just finding the sine. Let's start off by finding what angle will give us just regular positive 0.5. Because negative 0.5 doesn't really make sense in just the range of angles that we know. Now, sine of what will give us just 1/2 or 0.5? That's right, sine of 30 degrees. Because if you draw the special right triangle, the 30, 60, 90 triangle, you'll see that the sine of 30 is opposite over hypotenuse, which is just 1/2, which is equivalent to 0.5. Now, how does this help us with finding inverse sine of negative 0.5? Now, a property you have to remember of sine is that if you have sine of if you have let's say negative sine of some angle theta, this is equivalent to sine of that angle but negative. Alright, so basically you can drag this negative sign out and just have negative sine theta, or you could do the opposite. You could put this negative sign in and you'll have sine of negative theta. And if you look right here, well, if we multiply both sides by negative, we get that negative 0.5, and then we can put this negative inside of the sign, and we'll get that our angle has to be negative 30 degrees, which is equal to negative 0.5. Now right here, we're not given a degrees value, we're given a radian value, so we have to convert this to radians. So the way we do that is we take our degrees, we multiply it by pi over 180, and if you work this out, this will reduce down to negative 1 over 6 times pi, which would be negative pi over 6, and there we get a. Alright, so basically we find the angle, the positive angle first, and then we use the fact that this sort of it's because sine is an odd function, it's symmetrical across the x-axis. So if you have negative of sine, it's the same thing as sine of negative. So negative sine is equal to sine of a negative. Just remember that. Alright, our final question is inverse cosine of negative square root of 3 over 2. Now again, let's find out what cosine of what angle will just be the positive of that, square root of 3 over 2. Now we can see that it's going to be 30 degrees again. Alright, because if you look here, adjacent over hypotenuse, square root of 3 over 2. Don't know why I put square root of 30 there, sorry. But now that we have this, let's take a look at the unit circle, right? Right here, we're going to have like 30 degrees, and it'll be square root of 3 over 2, comma 1/2. Now, we have to move to some area that would make it so that we get negative square root of 3 over 2, right? So we'd have to go over here, because cosine is x. If we go to the other side, this will just be negative square root of 3 over 2, but the y value would stay the same. But we don't really care about the y value. The y value is sine, right? So square root of 3 over 2 is the x value, which is our cosine value. We need to go over here. Now, when you think about it, in this quadrant, to find the reference angle, you do whatever angle you have here, or you to find the reference angle, you take whatever angle you have here and subtract, or do 180 minus that angle. So 180 minus whatever angle you're trying to find here, and you'll get your reference angle, right? So, now we can work this out as an algebraic equation. So 180 minus our angle 30 degrees, or x, or let's call it x, is equal to 30 degrees. If we add x and subtract 30 on both sides, we'll get that x is equal to 150 degrees. Okay? You can move that around and do that. So, now that we have this angle right here, which is 150 degrees, we don't have a 150 degrees here, so we have to convert it to radians. So to do that, we do 150 times pi over 180. Now here, we can cancel out these zeros. We'll see that we can reduce this, and we can divide 15 and 18 by 3. So we'll get 5, and then this will turn to 6, and then we'll get 5 pi over 6, which gives us our final answer for this packet. I'm finally done. Sorry this took so long, and I know it's a bit late, and I feel like this video is going to come out even later, but I hope this helped with some of the concepts. I hope that if you're watching this late at night, this helps with review of some concepts. If you need more clarification, I can clarify in the comments, or but I don't think I'll be able to do a follow-up video in time because I have to go to bed soon. But yeah, I'm sorry I couldn't do this question right here. I hope it doesn't appear on the test tomorrow. If it does, you'll just have to make a wild guess, because everyone I've talked to, and including myself, I couldn't figure out, or we couldn't figure this out, right? It was just a weird and confusing question, and we just, some people guessed this, some people guessed this, something like that, but yeah. But now that this is done, I have to go put all of the, because I cut it a lot, I have to go put it all together and export it. So hopefully this helps you at Acer test tomorrow. It took really long. Oh god. But anyways, that's me done for tonight. Good night, everyone. Good luck on the exam tomorrow.